Identifying and graphing translated conics, part 2. So we're on to example 2 now, graphing the equation of a translated circle. So our translated circle has the form x minus h squared plus y minus h squared equals r squared, the radius. Okay, so r is the radius. There's our standard form right there. They gave us the equation x plus 1 squared plus y plus 2 squared equals 4. So we want to compare the given equation to the standard form of the equation of a circle. Okay, so we can see that from what we are given, all right, so the given information, remember we have, that should be x minus h, but we have x plus 1, which means that negative h equals positive 1. All right, so we need to remember that for just a second here. And then we have y minus k, which means that negative k is equal to positive 2. All right, so what we're now going to figure out here is that because the standard form is x minus h, that means that it's always going to take the opposite sign of whatever is inside the parentheses. So if it says x plus 1, well, that means that negative h is equal to 1, so that means that h must be equal to negative 1. And because negative k is equal to 2, that means that k is equal to negative 2. Okay. So from the graph, or from the equation, we can see that the graph must have h comma k of negative 1 comma negative 2. And of course, in a circle, the h comma k represents the center. So that means that we're going to place our center at negative 1 comma negative 2. So negative 1 comma negative 2. There's my center. Okay. And the radius, so r squared is equal to 4. Well, if r squared equals 4, then that means that if I take the square root of both sides, r is equal to 2. So we have a radius of 2. Plot the center and several points that are each, well, if the radius is 2, then we're going to go 2 units in any direction. So we already have our center at negative 1 comma negative 2. So we go 2 units up, 2 units to the right, 2 units down, and 2 units to the left. Okay. So what that does is we just take our original point and we'll say negative 1 comma negative 2 plus 2. That gives us our point up. Okay, so that would be negative 1 comma 0, which is exactly where we plotted it. Okay, and then we'll go to the right, so that would be negative 1 plus 2 comma negative 2. And that would give us 1 comma negative 2, which is exactly where we plotted it. Go down, so that would be negative 1 comma negative 2 minus 2, or negative 1 comma negative 4, right where we plotted that one. And the last one to the left, negative 1 minus 2 comma negative 2, which would be negative 3 comma negative 2. And again, right where we had it. Once you draw those points, then it's just a matter of sketching the circle to fit those points. And not quite perfect, but gets the job done. Okay. All right, on to example 3. Okay, example 3, writing an equation of a translated ellipse. So it says write the equation of ellipse with foci. Okay, important to know what we're talking about here. Foci at negative 1 comma 0 and 3 comma 0, and vertices at negative 3 comma 0 and 5 comma 0. Notice that it said vertices here and not co-vertices. So those are talking about the vertices of our major axis. Okay? So if we draw a quick sketch, first thing that it told us was our foci at negative 1 comma 0. So negative 1 comma 0 we have a focus, and at 3 comma 0, 1, 2, 3 comma 0 we have a focus. And then we have vertices at negative 3 comma 0. 1, 2 gets us to negative 3 comma 0. And 1, 2, 3, 4, 5, 5 comma 0. Okay. So we know the foci and we know the vertices. And because those both have to fall on the major axis, that means that we must have a horizontal major axis. So the horizontal major axis takes this form, the x minus h over, or excuse me, x minus h squared over a squared. Okay, a is always the bigger number in an ellipse. That's what indicates that we have a horizontal major axis, is because the a is underneath the x. Okay, the bigger number is underneath the x. And y minus k squared over b squared. Okay, so what we don't know, or what one of the things that we're going to have to figure out is what is b, because we don't know what that minor axis distance is going to be. And it always set equal to 1. All right, so the center must be halfway between the vertices. Okay, so in order to figure out where the center is, we would have to find the midpoint of our two vertices. So our vertices are negative 3 comma 0 and 5 comma 0. Our midpoint formula, of course, is x1 plus x2 over 2, comma y1 plus y2 over 2. So in other words, we're finding the mean of the x values and the mean of the y values. So that would be negative 3 plus 5 over 2, comma 0 plus 0 over 2. Well, that'll be easy. Okay, negative 3 plus 5 is 2. 2 over 2 is 1. And 0 plus 0 is 0. 0 divided by 2 is, of course, still 0. So 1 comma 0 is our center. And if we look on our graph and plot 1 comma 0, that makes sense. Right there in the middle. Okay. The value of a is the distance between the vertex and the center. Okay, so I pick either of my vertices to get the distance formula. Okay, so remember the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay, so if I pick, let's say 5 comma 0 for my vertex that I'm going to use, and I, of course, have to use my center, which is 1 comma 0. Now I could just count this off and figure out that the distance is 4, but we'll go ahead and do this the long way, just in case that's not the case. All right, so we do x2 minus x1, so that would be 1 minus 5, of course that's squared, plus y2 minus y1, so 0 minus 0 squared. All right, so that's going to just be 0. 1 minus 5 is negative 4. Negative 4 squared is 16. And of course, the square root of 16 is 4. And lo and behold, we have the distance that we expected. The value of c is the distance between the focus and the center. So this time I'm going to use either negative 1 comma 0 or 3 comma 0 and do the same thing. I'll use 3 comma 0 just because fewer negatives to have to deal with. So this time it's 1 minus 3 squared plus 0 minus 0 squared. Okay, again, zeros cancel out. 1 minus 3 is negative 2. Negative 2 squared is 4, which means that we have a distance, the center of 2. Square root of 4 is 2. Substitute in the values to figure out what the value of b is, because for an ellipse, it's b squared equals a squared minus c squared. So I take my a squared, which is 4, so 4 squared, so that's going to give me 16, minus 2 squared, which is going to give me 4. So 16 minus 4 is 12, okay, and all I need is b squared, right? Okay, because b squared is what goes underneath. So I don't need to figure out what b is. B, of course, would be just the square root of 12, but since that's not what it's asking for, I don't necessarily need it. I just take that 12, and I go ahead and plug it in for b squared. I take my 4 and plug that in for a, so 4 squared is going to be 16, and then I take my 2 and plug that in for nothing, because c is not actually in the equation. I don't really care about the focus or the foci unless I have to calculate either b or a, because remember, the actual equation itself only has a squared and b squared. So I'll go ahead and plug in my h comma k of 1 comma 0. So 1 is h, 0 is k. So on top it would look like this: x minus 1 squared over, and then we already said our a squared is 16, plus, and then we have y minus 0. Well, y minus 0 is just y squared over, and then b squared was 12 equals 1. Don't forget the equals 1.